In this video, we're going to have a look at how to divide a decimal by another decimal using short division. Now, on the surface, you think, well, how is that different from other problems that we might have looked at in the past? So let's have a look at, say, 3.21 divided by 0.3 for a starter. So on the surface, it looks like, okay, let's just start the way we normally do. So we go 0.3 goes into 3.21. And then now we have to make a decision about how many times 0.3 goes into 3 to start with, and that's when things get a bit hairy. It's not a nice thing to do at all. So we're going to use a little trick in order to work this out. Now, you might recall that we have looked at the division symbol as being a symbol which actually describes a fraction. Something over something. And you might recall that I have said before that if we have, say, 3 divided by 10, that's really just 3 over 10, like so. So we're going to use our method of expressing a division as a fraction in order to make our initial division problem easier to work with. So we had 3.21 divided by 0.3. Now this next bit I'm going to do as an explanation. I wouldn't actually do this in practice, but I'm going to write 3.21 as the numerator divided by 0.3 the denominator. Now we wouldn't normally write fractions with decimals in them, but we're doing it just to serve this point, and that is because 3.21 divided by 0.3 is just a fraction, 3.21 over 0.3, we can use our equivalent fraction logic to make our problem easier to deal with. And this is the way it works. I'm going to multiply the bottom number by a power of 10. Just a reminder, over to the side here, the powers of 10 are 1 followed by any number of zeros. So 10 is 10 times 1. 100 is 10 times 10. 1000 is 10 times 10 times 10, which we can write with index notation like so. The next one would be 10 times 10 times 10 times 10, which would be 10,000 and so on. They're all powers of 10. So I'm going to multiply 0.3 by a power of 10 in order to make it a whole number. In this case, I'm going to multiply by 10. Just a reminder that if I've got one decimal place in my decimal, by multiplying it by a 1 followed by that many number of zeros, I'm going to get it, the decimal point to move that many times. Okay, but equivalent fraction say that if I multiply the bottom of a fraction by 10, I can keep it equivalent by multiplying the top by the same number, in this case 10. So 3.21 times 10 over 0.3 times 10 will give me the decimal point moving once and the decimal point moving once, leaving me with 32.1 over 3, like so. So to make it really clear to you, what I'm saying is that 3.21 divided by 0.3 is the same as 32.1 divided by 3. It's the same. Okay, so we have done this, so we are now dividing by a whole number, which we have seen before and we can do. 3.21 divided by 0.3 is the same as 32.1 divided by 3. Now, if you don't believe me, put that into your calculator, look at the answer, then put that into your calculator and look at the answer. You will find they are exactly the same. Okay, so we use that trick in order to solve our problem, which I'll do right now. So we've got just undo that. So it's my division symbol there. 32.1 divided by 3. We write it in short division style, 32.1, and away we go. 3 goes into 3 once with no remainder. 3 goes into 2, it doesn't, so I'm left with a 0 there and 2 remainder over the decimal point, and I'll copy my decimal point up to the top. 3 goes into 21 7 times, exactly, no remainder, no more decimal places, I'm done. So 32.1 divided by 3 is 10.7, so therefore 3.21 divided by 0.3 is equal to 10.7. There's no need to switch back the decimal point or anything like that because they are equivalent. 32.1 divided by 3 is the same as 3.21 divided by 0.3. Both of them give me the answer 10.7, and you can confirm that on your calculator if you don't believe me. Let's have a look at another example, and I'll do it without all the fraction stuff this time. So let's just say I've got 6.182 divided by, I don't want to make it too hard for me, divided by 0.04, like so. So what I do is I look at the second number, the number I'm dividing by. So that's this number here, yeah? This is the number I'm dividing by. Look at the second number, and I work out how many decimal places I have to move it in order to get it to the end. Because once the decimal point is at the end, it'll be a whole number. In this case, I've had to move it twice. And then I look at the first number and I move it the same number of places. So again, just to spell it out, it's the second number which will tell us how many times to move the decimal point. However many times I have to move it in the second number, I just repeat that in the first number. Okay, so that gives me, just change my colors, that gives me 618.2, so 618.2 divided by 4, which I can now do as a short division. 4 goes into 618.2, so 4 goes into 6 once, 4 times 1 is 4, so that leaves me with 2 remainder. 4 goes into 21 5 times, because 4 5s are 20, and that leaves me with 1 remainder. 4 goes into 18 4 times, 4 4s are 16, that leaves me with 2 remainder. Put my decimal point in, put my remainder over the decimal point, that's fine. 4 goes into 22 5 times, 4 5s are 20, with 2 remainder. I've run out of digits, but I can add a 0 in, no problems. 4 goes into 20 5 times, no remainder, no more digits, I'm done. So therefore 6.182 divided by 0.04 is exactly equal to 154.55. Okay, one more exam, I think that will do us. So how about 2.879 divided by 0.0007. Yeah, that'll do it. Okay, so same process. I look at the decimal point here and I say I have to bounce it once, twice, 3 times, 4 times. And so I have to bounce this once, twice, 3 times. Uh-oh. I've run out of places, but I still need to do the right number of bounces. So again, because this is a decimal number, after the decimal point, I can add zeros to my number without it being a problem. And so there's my 4th bounce there with a 0. And so I can say that 2.879 divided by 0.0007 is simply equal to 28790. So 28,790 divided by 7. And you might think, well, that looks a bit weird, but you can sort of see that I'm dividing 2.879, so what, almost 3? But I'm dividing it by 0.0007, which is really tiny. So even though 2.879 is a small number, I'm dividing into such tiny parts, I'm bound to get lots and lots of parts. Okay, which is why it is equivalent to, which sort of hopefully explains why it seems okay that 28,790 divided by 7 will give us the right answer. Okay, anyway, let's do that as a division. So we've got 7 into 28,790. And let's go for it. So 7 doesn't go into 2, but it does go into 28 because 7 4s are 28. So I'm going to go straight for a 4 there with 0 remainder. Then I've got 7 goes into 7, and 7 goes into 7 once with no remainder. That's pretty good so far. 7 goes into 9 once as well. 7 1s are 7 with 2 remainder. 7 goes into 20 twice. 7 3s are 21. So I'll go in twice. And I've got 6 remainder, but this is decimal division, so I'm going to add a decimal point here and copy it up there, pop another decimal place in, put a few in, don't know how many I'll need, but I'll just put 3 in to see how I go. So what was it? 7 goes into 20 twice, 6 remainder. Alright, 7 7s are 49, 7 8s are 56, so it looks like it'll go in 8 times, 7 8s are 56, that'll give me a remainder of 4. And then I've got, was it 7 4s 28, 7 5s are 35, so it looks like it'll go in 5 times with 5 remainder. 7 goes into 50, 7 times, 7 7s are 49, and that'll give me 1 remainder. And as you can see, I'm just adding in zeros now and extending my division line and see whether I can get a pattern here. I might not be able to, but let's see how we go. 7 goes into 10. Well, once, isn't it? 7 1s are 7 with 3 remainder. 7 goes into 30 4 times. 7 4s are 28. So that will give me 2 remainder. 7 goes into 20 twice with 6 remainder. 7 goes into 60 8 times with 4 remainder. I don't know if you've seen it yet or not, but I have. That there is definitely a pattern happening here. So it's a long one though. So if you look from here, you can see that that's where it started repeating again. But this is on the other side of the decimal points. We can't include this 2, but I can see that I'm going to get a repeating pattern. So there's a 2 on this side. But then we've got 8, 5, 7, 1, 4, 2, 8, and I can guess that the next digit is going to be 5, 7, 1, 4, 2, 8, and so on. So once I see the pattern, I can stop. So the final answer is going to be, therefore, remember that first number we had didn't look so scary, did it? 2.879 divided by 0.0007 is equal to 4,112.857,142. Repeating. That's a big repeating set of digits there. And that's your final answer. That's your exact answer. To be honest though, if you are doing a division like this, and you don't need it to be exact. So for example, the question might be not asking you to make it exact, or in a test paper or an assignment, or because you're doing some sort of measurement and you know how accurate you need to make it. Clearly you don't need to go to all these decimal places. I mean, it's great that we've got an exact answer now, which is really what you want. But if you're doing a division and you really just need the first couple of decimal places, then you would continue this division until you got to one more decimal place. So in this case, if I was doing it to 2 decimal places, I would use my division to 3 decimal places, because the 3rd decimal place is my critical digit and it tells me whether to round this one up or not. So if I was rounding to 2 decimal places, I'd go my division to the 3rd decimal place, oh, it's a 7. So to 2 decimal places, I would write 4,112.86 and then put in brackets 2 decimal places. So that's it. That's how you divide a decimal by another decimal. Step 1, bounce the decimal place in the second number as many times as you need to get it to the end. Step 2, bounce the decimal place in the first number the same number of places, adding zeros to the end if you need to. And then step 3, divide through as you would normally.